My name is Tim Gould. I am the IEA's Chief Energy Economist, and I will be hosting today's discussion. I'm joined by colleagues from the Critical Minerals team, the head of our Critical Minerals division, Tae-Yoon Kim, and also the lead on this report, Amrita Dasgupta. But I'm particularly pleased to welcome also Benjamin Galuzot, the Interministerial Delegate for Strategic Minerals and Metals Supply from the French G7 presidency. This issue has been a big priority for the G7 presidency this year, and we're very, very pleased to welcome Benjamin to this launch event. This is an issue where we have been providing input and support to the French presidency, alongside the other energy issues that, of course, you're aware of that are in the news. But before passing Benjamin the floor, just a few words of introduction, because here at the IEA, we have been expanding our work on critical minerals over the last few years, reflecting the way this has moved up the international policy agenda. And during the IEA ministerial meeting, which took place in February this year, IEA ministers agreed a political declaration welcoming different dimensions of the IEA's work, including work with our member countries on a critical minerals security program, which they saw as a key international platform to support countries in enhancing emergency preparedness and promoting supply diversification. And in parallel, I hope many of you are familiar with the public-facing work that we've done, the data that we provide, the analysis that we provide, including in our flagship Global Critical Minerals Outlook, which we are now preparing for a launch a little bit later this year. So this special report on pathways to secure and diversified rare earth supply chains is an example of our priority to provide up-to-the-minute data analysis on topical questions around critical minerals. Of course, we're all aware that we are in an energy security crisis with the conflict in the Middle East. And I think we need to distinguish the sorts of energy security risks that we see in critical minerals from those that we see in fuels. Clearly, when there's a shortfall or a price spike for fuels, it affects everyone that is using those fuels, whereas critical minerals are inputs to some key technologies also in the energy sector. And so it affects the flow of those new technologies, the cost of those new technologies into the system, rather than affecting all users in the way that you have with fuels. But there are nonetheless some very key strategic issues at stake here, because those rare earth elements that we're focusing on in this report play a really essential role in enabling a wide range of strategic downstream industries, from energy and high-tech to aerospace and defense. And those supply chains, as we've emphasized in previous analysis, are extremely concentrated. In fact, for rare earths, they are the most concentrated of all the strategic minerals that we've analyzed here at the IEA. And we've long warned of the potential security risks that brings. And 2025 was the year in which those risks materialized at scale, with the series of export controls announced over the course of the year. So although the main export controls announced by China in October 2025 were suspended for 1 year, there is, in our view, no room for complacency on this topic, and we need to be vigilant in ensuring secure rare earth supply chains. And we're responding in this analysis to the need for clear pathways and concrete actions to advance diversification in this area. And the report, as we'll hear in a minute, sets out 8 key recommendations in this regard. But before we go to the detailed findings, again, welcome, Benjamin. I would like to pass you the floor to talk a little bit about your G7 priorities. And thanks again for joining.
Thank you very much, Tim, and thank you very much for the International Energy Agency for inviting me to this release of this very important report. A few highlights on how the G7 and its partner are discussing this question of critical mineral and especially rare earths. So the subject has been taken now in the G7 since 2023 under the Japanese presidency, then followed by Italy and last year by Canada. And it is obviously one of the very important subjects of the G7. And at the leader level, there is a consensus that this subject has to be, I would say, dealt with at the highest level and with the highest level of cooperation. So at the start of the French presidency, it was identified as a priority. In continuity with what has been done during the Canadian presidency, we have put in place a special organization to deal with that subject, because it's various tracks of the G7 are concerned by this situation. So we have created a high-level group to coordinate all the activities, and discussion have been very positive on this subject. We have mainly four areas of work. The first one, very important, is supply side measure, and it's very oriented to develop operational project and to increase the level of financing inside the G7. There will be, by the way, next week at the IMF spring meetings, a discussion of the development banks to increase their investment in critical minerals. And there will be in Paris in the 10th of June an event with all the financial industrial community to increase the investment in critical minerals. So that's the first pillar, very operational, very result-oriented on delivering a project and bringing more investment. But we know, and the report highlights that very well, I think, in the case of rare earths, that we need also to have a proper market environment, a proper price environment, price visibility, price transparency. And this is, I would say, the second pillar of our G7 discussion, which is how we can create a market which is very adapted to the situation of critical minerals, and especially those like rare earths, where you have which are small market and not very well organized. And as you know, there are very important discussion on how we organize trade, how we organize some kind of regulation of the price environment. And these are, of course, ongoing discussion, but the G7 discussion will be a way to accelerate decision, which will be a way also to give a clear signal to the market that the problem that impended during last year investment in critical minerals are solved through a kind of regulation, a kind of market environment which gives predictability to the investor. The third part is related to transparency and traceability. It's true for all kinds of critical minerals. To have a good market environment, we need a transparency on where do the mineral come from, and traceability. And this is really key, not only for market reason, but also for environmental, social, and governance question. And we want to, through selecting a limited number of critical mineral, make a step further on traceability and transparency in this market. Another subject in this pillar is stockpiling. We consider that the level of stockpiling inside the G7 country and partner has to be increased, and that we have to coordinate our policies on that. There is a similarity with the question of stockpiling on energy market, but also very important specificity, because you have 50 critical minerals. We have these are included in very complex value chains. So clearly there needs to be a kind of high level of cooperation between countries on how we design and use our stockpiling. But the general message is we have to increase the level of robustness and resilience of our supply chain through stockpiling. And the last pillar is related to innovation and circularity, recycling. We know, and the report shows that there is a very huge potential to increase the resilience of our supply through recycling and through innovation. change of use, diminishing of use of critical minerals in equipments, new mining techniques, new exploration techniques, new processing techniques that are more efficient. And this is one of very important subject. In the G7, we work also with other countries, especially Australia and Korea, but more largely Brazil, India, also Kenya, which is associated to the G7, considering that we'll have a summit, also African summit in May. So, and many other countries around the world. We consider that cooperation, international cooperation, is really key. We want to make it a multilateral effort and a joint effort. It's not a closed discussion. It's something that involves and will involve the effort of a lot of countries. Lastly, and some point on, I mean, where are we precisely? And in the case of rare earths, I think there have been already a lot of effort done, and the report mentioned them. All around G7 country, but also in Australia to increase the level of production, to develop new mine. And as far as France is concerned, since the launch of our strategy in 2023, we put the question of rare earths at the top priority of our policy, and especially we invested a lot in a new separation facility which will come into operation next year for heavy rare earths. It's 20% of the world supply of heavy rare earths, so it's very significant. And we are also, French companies also investing in existing refining capacity in La Rochelle in France. So if you take this example and also the effort done in Europe, in the United States, in Australia, in Canada, in Japan, in all the country, in the UK also, we see that diversification is feasible. It takes a significant number of years, but it's achievable at a reasonable cost. But it needs consistency, it needs a duration, it needs consistent policy, and in that respect, we of course welcome all the recommendation of this report. Thank you very much.
That's great, Benjamin. Thank you so much for that, and indeed for all of the collaboration that we've had with you during the presidency. I think you provided that high-level framing, but also brought us back down to where we need to be, which is very much at that project level. The real achievements that we need in order to create those more resilient supply chains. We will move now to the presentation of the report's findings. So I'm going to hand it across to Taeyun and to Amrita. But just to note that there will be an opportunity for you to ask questions after the presentation is done. So if you would like to do so, please just put them in the Q&A function of Zoom. We will pick them up and we will come to those a bit later on. But with that, Taeyun, Amrita, over to you.
Thank you, Tim. So in recent years, the rare earth element, a group of 17 different elements, has rapidly moved to the forefront of the global energy and industry policy makings, because they underpin some wide range of strategic applications, from energy to AI data centers to robotics to the aerospace and defense applications. And all elements are quite crucial. All 17 are important, but there are some particular for the major elements that are used highly in the high performance magnet making. Those are neodymium, praseodymium, and dysprosium and terbium. Those four magnet rare earth elements account for around half of the total rare earth consumption by volume. But when you look at this picture by value, and they represent around 95% of the total value of the whole rare earth element consumption, highlighting the important role in these pictures. And they are also the main driver, is fast growing the sources of demand growth going forward. For this magnet rare earth element, and we are expecting demand has actually, since 2015, demand actually has doubled, driven by the electric vehicles and wind. But we think this demand is set to expand further by a third to 2030 under today's policy settings. And this is driven by the new segment of demand is emerging from electric vehicles, robotics, high techs, and wind, joining these traditional uses of these applications. But on the supply side, when looking at supply side, supply of magnet rare element, as Tim mentioned, and remains among the most geographically concentrated among all the key strategic minerals analyzed by the IEA. On the mining side, the concentration level has declined over the past decade as new projects come online in different parts of the world. But still, the two major producing countries, China and Myanmar, account for around 3/4 of global mine productions. But the picture looks less favorable for the refining and magnet productions. For refining, over the past several decades, the level of concentration has been persistently high, around 90%. Today, they sit around 91%. For magnet making, some 20 years ago, in 2005, China accounted for around 50% of the global magnet production. But after 20 years, by now, they represent around 94% of the global magnet production, highlighting some worsening situation in terms of concentrations. This high level of concentration creates some potential supply security risks. And as Tim mentioned, the 2025 was the year that this risk of high concentration materialized at scale due to some range of export control announced by the dominant countries. In April 2025, the Chinese government introduced export control on 7 heavy rare elements and their related compound and magnets. And after the export control, and many automakers from in Europe, United States, and other parts of the world had to cut utilization or even halt operation on a temporary basis because they couldn't secure the magnet. And since July, the trade volumes has recovered, but the price levels still remain quite high in importing regions compared with those in the incumbent, the Chinese. The prices remain indicating some quite notable premium for ex-China magnet, and that has an implication on the manufacturing operation in these importing countries. In October 2025, the Chinese government announced another major export control. This beyond expanded scope of materials and also on technologies, equipment, and one big notable feature is this control included the new licensing requirement covering also the internationally made product produced using Chinese materials or Chinese technologies. And this is quite significant development in our view, posing major risk to the global energy and economic security risks. And in November 2025, this export control was suspended for 1 year. But if this export control was implemented in full and trade flow were disrupted, and then economic value of downstream production at risk would be huge. We are estimating around $6.5 trillion per year across US, Europe, Japan, Korea, and other parts of the world. And the automotive sector would be most affected in terms of sectors, followed by the high-tech, energy, and defense applications. And these analyses highlight two things. There's some reduced scope of complacencies for rare element securities. And second, there's some urgent need to diversify the supply chains to reduce some of the structural risks. And then the next question is how we can diversify the rare supply chain. The first step, the fundamental starting point, is to have some clear understanding about the demand outside of dominant suppliers, both today and the futures. This is crucial to assess the need for future capacity expansions and gauge the required investment scale, and also coordinate the policy effort among the like-minded countries. And under today's policy settings, the demand for magnet rare element outside of dominant players set to grow by 50% by 2035, driven by the electric vehicles and other applications. But then on the right side, today's existing capacities outside of dominant players very much lacking to serve this level of demand. And some positive development is there are some planned expansions from existing projects that will add some new volumes to the supply, but still there's some quite number of gaps to close. And in the case of full coverage of the ex-China demand, the world needs to scale up the mining, refining, and magnet capacity by the factor of 2, 4, and 6, respectively, to deliver the goal of diversifications. And the planned project in the pipeline will help if they come online on schedule and on budget, and they will have to close this gap. But there's some more need to be done to fully close these gaps. And it is encouraging that there's many projects are being announced and being developed in recent months, because of the export control, but other imperatives. But we want to highlight some imbalances we see in the supply chain development. It's very encouraging that we are seeing the large number of projects being announced and being developed. But when you look at the picture of the existing and planned capacity outside of the dominant player, the scale of project pipeline for mining, there's a fair amount of projects being planned and developed in the mining side. But the project pipeline for refining is much smaller, and the same for magnet production is much thinner. So there are some imbalances in the project development. So even though you produce mined materials outside the dominant players, still the need to rely on other countries to separate, refine, and produce magnet. And this, especially the magnet production, is particularly important because they can provide some robust demand base for upstream the material production. So we want to highlight this bottom, more attention on should be given to this bottom, the part of these pictures. And delivering this diversification goal requires a major increase in investment amounting to around $60 billion in our estimation over the next decade, was from public and private sources. The refining accounted for nearly half of this total investment need, while the magnet productions represented around 1/3. And this $60 billion looks sizable, but when you compare with some huge investment need for the energy minerals such as copper mining, for example, copper mining requires around over $250 billion over the next decade to deliver the expected level of demand. And compared with this size and this level of investment, $60 billion looks relatively modest and manageable. And the same is true when we compare this with the huge economic impact of supply disruptions we discussed. And the one key question is the rare project outside of dominant players typically face some higher capital and operating costs. So that makes it challenging to attract much needed capital investment to deliver this project. That requires some well-designed policy measures both on the supply side and the demand side. Supply side, there are two categories. One is capex measures. The equity investment, grant, loan guarantees, they are all very useful to reduce some of the upfront capital requirement and then get this project up and running. But in some cases, like the rare element where the market is very small, the level of concentration is very high, and if there are some supply disruption, economic impact can be huge. There's also need to consider some OPEX or risk mitigation measures such as contracts for differences, price cap and floor, and offtake backstop to reduce some of the price or volume risks. And contracts for differences or price cap and floor are widely used in other markets to reduce the price risks. And offtake backstop is some widely used tool to reduce the volume risk and provide some degree of volume certainties. But even though you succeeded in developing this project and get this project to come online, get up and running, but if there's no motivation from consumers to buy materials from these suppliers, then there can be the partial success. So that requires some of the thinking about demand side measures. The first step is nurturing the downstream industry development in these countries. The EVs and the AI, robotics are all the future-facing industries, and that benefit from some kind of tax credit or other form of support. So nurturing these downstream industries also provides some solid demand base for this magnet and for the rare materials. And second is one could consider the diversifier or supplier sourcing obligations, such as setting the portion of the procurement coming from diversified suppliers. And this can be coupled with some kind of tax incentives to neutralize impact on downstream consumers. And also trade measures could be the option being discussed in the marketplace. So by combining the supply side and demand side measures and can help move this project going ahead and then make some progress. And there are some cross-cutting enabling measures, such as widening pool of the accessible financing sources. And as Benjamin mentioned, the involvement participation of the DFIs and ECAs can be crucial in this respect. And there's also another important element, such as permitting, the partnership standard, and traceability all can play some important role in delivering the goal of diversification. And I will turn to Amrita for the explain some of our 8 recommendations to ensure rare market securities.
Thank you, Tim. This report was really motivated by the need to identify priority action areas. So in the final chapter, we've outlined 8 key considerations for policymakers that can help to strengthen supply chain resilience and security, as well as support long-term diversification efforts. Theron just explained really well our analysis on financial and policy support that feeds into recommendation 4 that you see here on the slide, but I'm going to walk you through the rest of the recommendations as well. The first one is really to develop a clear understanding of national demand outlooks and vulnerability to supply shocks for different domestic industries. Such an analysis is really essential to define realistic capacity targets, estimate the scale of investment that will be required, calibrate policy instruments in order to minimize fiscal burdens, and identify the priority segments and industries across the value chains domestically. The second recommendation is to enhance emergency preparedness to safeguard against sudden supply shocks. An effective emergency response system would include the following parts: market monitoring to rapidly identify and assess disruptions, clear procedures to enable swift and coordinated action, regular exercises in order to strengthen response capacity, and finally, the measures capable of delivering meaningful market impacts when disruptions do occur. These measures are, of course, most effective when developed in close collaboration with international partners. I will come back shortly to recommendations 3, 5, 6, and 7 in a little bit more detail, but the final recommendation is one that highlights the need to work towards market transparency. Price transparency is really an essential feature of all well-functioning markets, and the absence of such transparency in rare earth markets hampers the creation of key financial tools that are commonly used to assess risk in other commodity sectors. During our research and discussions with industry experts, it became quite clear that diversification is not simply a question of the intention to develop new projects. There's really a much broader ecosystem issue that needs to be addressed for diversified projects to become competitive, and this is what we highlight in recommendation 5. Rare earth value chains, as mentioned already during the first part of today's session, really rely on a multitude of complex technical processes requiring not only specialized equipment and machinery, but also skills and training to produce the outputs that conform to strict industry specifications. In many cases, there are very few equipment and machinery suppliers outside of the top producer, making this equipment a lot more expensive, and the time required to obtain the equipment with required specifications can really span several years longer than in the dominant producer. Also, export controls covering a wide range of technologies and equipment going from mining to separation and processing and finally magnet manufacturing as well really highlights the urgent need to pay attention to closing these technology bottlenecks in parallel with developing new projects. In our analysis, we identified at least 8 key areas of concern across the supply chain that could be either in equipment, machinery and reagents. An example of this would be electrolysis cells with high energy efficiency used for the metallization process that comes just before magnet making, or the bottlenecks could also be in knowledge, such as the optimized equilibrium data on pH and temperature for solvent extraction, which is used to separate rare earth elements, or it could be a combination of these bottlenecks as well. The gaps that we see today in costs and in lead times are really a function of the high levels of supply chain concentration and the lack of major industrial bases outside of the top producer. But as efforts to diversify rare earth supply chains are ramping up, there is really a potential for competitive markets for equipment and machinery to emerge. And this brings me to touch upon recommendation 6, which is on promoting supply-side innovation as a key enabler which will help reduce the technical, economic, and environmental barriers that are faced by new entrants. Without additional policy support and R&D efforts in technology and innovation, closing the existing gaps in geographically diverse regions and ensuring the competitiveness of new projects will become highly challenging. And as a complement to this, we talk about demand-side technology innovation in the next recommendation. Demand-side innovation can really be a powerful complement to supply-side measures, providing a pathway to alleviate constraints as well as help during geopolitical tackle geopolitical risks. The rare earth content of different magnets can vary significantly based on the application and the performance requirements. For example, high-performance EV motors can really have the highest content by weight of heavy rare earths such as dysprosium and terbium, whose supply is generally more constrained and prices are higher than those of light rare earths. Demand-side innovation can really take three distinct forms. The first would be to reduce the amount of heavy rare earths that are required within existing chemistries. The second would be to substitute one heavy rare earth with another that is less supply constrained. And the last one would be developing entirely new technologies that minimize drastically or eliminate rare earth use altogether. So far, we've seen that the most successful innovation in alternative magnet technologies has been incremental, really focusing on either replacing one heavy rare earth with another or trying to reduce the intensity of heavy rare earth use. But we think that with renewed policy and R&D efforts, rare earth-free technologies like iron nitride could also play an increasingly important role in order to reduce the burden on rare earth supply chains. Coordinated action across the value chain can really accelerate demand-side innovation. For example, collaboration among end users, which are motor manufacturers, and magnet producers and public authorities is particularly effective in overcoming technical barriers and creating supportive policy frameworks. Such a coordinated approach has helped Japan reduce its demand for rare earths after the 2010 rare earth supply disruptions. And then on the recommendations, last but definitely not the least, is recycling. Recycling can offer dual benefits by reducing the reliance on mining and strengthening supply chain resilience. Manufacturing scrap currently accounts for a majority of secondary supply and is heavily concentrated in China, where most permanent magnets are produced today. However, there is hope. Rapidly growing end-of-life volumes from EV motors, wind turbines, and electronic waste offer a major opportunity in regions with higher levels of technology deployment. By mid-century, we see that recycling can lower the needs for primary supply by up to 35% under today's policy settings. Europe is particularly well positioned in this regard, projected to generate about half of global magnet scrap from wind and about a quarter from EVs by 2030. Key measures to scale up these benefits of recycling really include boosting collection rates, especially for EV motors and wind turbines, harmonizing extended producer responsibility schemes, and introducing rare earth-specific recovery and labeling requirements. Also, de-risking investment in recycling infrastructure through grants, feedstock access programs, and recycled content incentives can also play an important role in order to scale emerging recyclers and technologies. And finally, before we close today's presentation, I would like to highlight that no supply chain is free from environmental concerns, and addressing them is really an essential part of project development. Rare earth supply chains can generate various environmental impacts across different stages. For example, in situ leaching, which is the dominant extraction method for ionic adsorption clay deposits, which are rich in heavy rare earths, can produce acidic leachate and radioactive tailings that, if improperly managed, can contaminate water bodies, soils, and surrounding ecosystems. Processing also introduces concerns such as air emissions and community health impacts from high-intensity chemical operations. Also importantly, many rare earth-containing ores frequently co-occur with radioactive elements such as thorium and uranium, and extraction activities can concentrate these naturally occurring radioactive materials into tailings and process residues, which would require careful planning and investment efforts to minimize the environmental impact. Addressing environmental risks really requires international coordination on regulatory standards and support for technology development. Regulatory standards, in particular for naturally occurring radioactive material management, remains fragmented across producing jurisdictions and would really benefit from greater international coordination. And with this, I thank you for your attention and pass the floor back to Tim.
Thank you very much indeed to you and Amrita. We're going to take a very short break now. We would invite you to submit your questions in the Q&A function. We're also just going to rearrange the chairs a bit and bring in our colleague Eric Brisson to the panel discussion. And so we'll take another 20 minutes or so after the break to have a little bit of a discussion. So see you in a couple of minutes. All right, thanks very much, everyone, for the questions. And we're delighted that so many of you could join today's webinar and discussion. I think I might start with a question to Benjamin, because you mentioned during your remarks up front also the issue of involving sort of non-G7 players and other stakeholders. So how do you do that in practice? I mean, you mentioned Kenya, I think you mentioned Brazil. So how does that work?
So thank you very much. So first of all, it's clear that this question of rare earths and critical mineral in general, I mean, it's a very perfect example of how the international cooperation has a lot of value in collectively bringing more resilience in supply chain. It's really not something which only one country or a small group of countries can do. It's really a collaborative and international question, because as you see, there are several steps, several very complex value chain, and a lot of countries have a very big role to play. So, I mean, already in Europe, in France, and other G7 countries, we have a lot of international partnership on this subject. We also value very much all the work done in the international agency organization, in OCDE, and especially in the case of G7. So first, we have a clear discussion with Australia and South Korea, who are directly associated to part of our work, but also Brazil, India, and Kenya, which are outreach partner of G7, that are where we have discussion, and all of these countries have a very important role to play in rare earth diversification. And more broadly, I mean, during all this year, during the various mining conference, starting as a Future Mineral Forum, where we had very interesting discussion at the ministerial level, Mining Indaba in Cape Town, the PDAC in Toronto, all these forums were opportunity for us to discuss, I mean, France, but also other G7 countries, to discuss with all these partners and get their inputs on what are their priority, what they can bring as effort, and I think we really need all the leadership of a lot of countries, and this discussion during the first semester were very good. Then there will be also Africa Forward Summit in May, where a lot of African countries will be interested in discussing this question. So I would say all these outreach contribute to the input. There is also a close link with what is done at the G20 level during last year South African presidency, and during this year US presidency. So I think that there is a very good level of international cooperation, and the idea is not to exclude, it's not to have something close, it's really to take the maximum in this multinational area. It's a question of diversifying supply. It's not a question of creating, I would say, autarky on small part of the world. This is not the idea where we go forward. And you know, the need for rare earth permanent magnet, it's all economy, all country will need that. All country have an interest of diversifying their supply.
That's great, Benjamin. Thank you so much for that. We've had a few questions on the linkages between the critical minerals discussion, in particular rare earths, and the development of AI, data centers, digital infrastructure. Tayun, would you mind taking on some of those connections?
Yeah, sure. So rare earth element is very much crucial for energy technology such as EVs and wind, but they are also very critical role in the high-tech applications, including AI chips and data centers. and particularly for the magnet rare earth element. And they find some application in high performance, the application in motors, in cooling fans, precision actuators, and hard drive assemblies, and in much smaller quantities in optical the component. And they are all very central or play central role in the data center use. So there's some increasing as AI data centers increase, and there's some increased demand for the rare earth element for these applications. But the one need to put in the context about the scale. So when we assess the scale of the rare earth demand in these data center applications, and it accounts for around the 1 to 3% of the total rare earth consumption by volume. So still relatively modest at today, but given the scale of the pace of the investment growth for data centers, it can account for much larger portion in the coming years.
Thanks very much indeed, Tayin. I have a question has come in on recycling, and it's talking about some elements of the report where you talk about mandating rare earth content disclosure and relevant products could be considered to improve traceability and sorting efficiency. So in terms of recycling, could we say a little bit more about our thoughts on labeling digital passports for products containing rare earth elements or on the permanent magnets themselves? And maybe, Eric, if I could ask you on that one.
So maybe on recycling, recycling comes with two key opportunities and perhaps two limits for diversification. So on one side, there's optimism in terms of reduced demand from primary extraction. And so we're talking about 35% of supply that would come from secondary sources, so both manufacturing scrap, but also end-of-life products. And the second opportunity is the new feedstocks. We're talking about EV motors and wind, which when they reach their end of life will probably be a bit more recyclable than the smaller magnets you have in typically electronic waste. And so by 2035, about half of the end-of-life magnets feedstocks in wind will be available in Europe, and about a fourth for end-of-life EVs. And so that can play a role in diversification. The two challenges is that a lot of the current feedstock is manufacturing scrap, and of course manufacturing scrap is produced in the dominant producer. And so that amount will play a smaller role in diversification. And then the second challenge is, of course, that the technologies we're talking about, EV motors, etc., are ramping up quickly, but they haven't reached their end of life yet. And so there'll be a slow process to get those markets, those feedstocks to get into the market. There's a lot of hope. We've looked at a number of startups. They're currently competing for limited feedstocks. So one of the areas of action is to think of the ways we can make sure that they have access to feedstocks to develop their capacities. And then collection is the main challenge. But the good news is that some regions are already doing quite well in terms of collection rates of waste, and expanded producer responsibility schemes play a significant role in that. But then, as we mentioned, on the EU side, we've been looking at a set of new policies, trying to look at, for example, the amount of rare earth elements available in the products, making more information available on how to retrieve the magnet from the product. And so that's a type of regulation that hasn't been implemented yet, but will be in the next few years. And so that's creating a number of opportunities, and we'll be looking into that in the future.
Thanks very much indeed, Eric. We've received a few questions looking at different regional aspects of this, and there's two in particular focusing on Southeast Asia. So if we consider the countries of ASEAN, what role do we think they could realistically play in these emerging supply chains? Would they be better positioned in the resource development, processing, manufacturing, broader strategic diversification partnerships? Could I ask Amrita to say a few words on that?
So this is actually a really interesting question, because the ASEAN region or Southeast Asia actually plays a very important role in rare earth supply chains. Today, the largest rare earth refinery outside of China happens to be in Malaysia, which is owned by an Australian company called Lynas, and this is really one of the most critical diversified projects for rare earth elements. But beyond this as well, the Southeast Asian region is home to a lot of today's known rare earth reserves. And we already know about the role of Myanmar, but moving beyond that as well, Vietnam has significant reserves and is also looking to move along the supply chain more towards processing as well as magnet manufacturing. And we've also seen other countries such as Thailand emerging as major magnet manufacturing countries. So what I would say is really that the same ecosystem bottlenecks that the rest of the world has to tackle are the ones that the Southeast Asian region would also have to look at, and really to develop a successful rare earth ecosystem in these regions. The priority would be to address the gap in the equipment costs and lead times, providing really targeted subsidies and incentives to existing and emerging equipment and machinery producers. Also building a consortium of domestic or international equipment producers to coordinate production of components and equipment can also really realize scale advantages. And working together as a region, I think ASEAN could really play an increasingly important role in rare earth supply chains.
Thanks very much indeed, Amrita. So I haven't been naming the questioners, but there's the names that occasionally do pop up on the Q&A. So this one's from Nektagan with Bloomberg News, and there's a couple of different aspects of this about the challenges. What's the biggest bottleneck to establish alternative rare earth supply chains outside China? Do we have a feel for how long that could take? And do you see any difference in this between light rare earths and heavy rare earths? And maybe I could ask Tae-Yoon for his thoughts on that one.
Yeah, so the question about the refers to the biggest bottleneck, but there are several big bottlenecks I should mention. The first is about this ecosystem issue that Amrita explained. So building this new, especially refineries and separation plant and magnet plant requires some specialized skills and technologies, machineries, equipment. But today, at the moment, then most of the equipment, machineries used in this plant are available in dominant countries and not available in the outside of these players. That requires often the sourcing this equipment machinery can spend multiple years and take some long time, and the cost is much more expensive. So that is one of the key, the bottleneck, some concerted effort to address this technology ecosystem bottleneck is one key issues we highlight in the report. And another thing is obviously about financing aspect. The much needed capital to mobilize make this project happen is very much important. But there are some various measures and tools being discussed in the marketplace. But in our view, one important thing is to understand their trade-off, because those measures have an impact on both the project economics, but also have incur some level of fiscal cost. So how we can design this scheme well by balancing this trade-off, understand this trade-off is very much important task one need to do. For example, price cap and floor, it can be useful, but there is important keyword when you design this scheme. For example, the performance linked, tender based, and both cap and floor and time bound. There are some important consideration to design this instrument well. And the third aspect is about the lack of demand side incentives. Is one of the biggest bottlenecks, because the downstream application provides some solid, robust, demand-based, offtake-based for upstream project to move ahead. So in that sense, I highlight the importance of magnet productions, because magnet production is very much highly concentrated. That is one important pillar, but also once they come up online, then they can provide some robust, solid, the demand basis for upstream supply chain development, such as refining, separation, mining. And in doing so, also the beyond magnet in manufacturing of motors and other downstream applications very much crucial in this respect to give some demand side incentives.
Thanks very much, Tae-Yoon. I'm going to come to Amrita, because there's a few questions on environmental impacts. So how can we work on those, ensuring that we have sort of environmentally responsible development of rare earth elements? And then there's another sort of set of issues around international cooperation. So what are the areas where you see that being most valuable? And then I think we'll probably, after that, we'll go to Benjamin for any final thoughts from his side, and also maybe some thoughts from you, Benjamin, on next steps for the G7 presidency. But maybe Amrita, please, first.
So once again, a very valuable question. in terms of environmental impacts, actually the two questions can kind of be linked. Also, to manage environmental impacts, we need international collaboration. But I think the priority is for environmental impact assessment to really be a part of project development. It has to become an intrinsic part of any new project that is being planned. And so assessments on how different stages of the supply chain will impact the local ecosystems, as well as worker safety, and all these aspects really have to be considered while designing a new project. And in this regard, of course, international collaboration is encouraged for handling these concerns, especially among countries that would be able to implement the policies in coordination through the help of groups such as the G7 and the G20. And then on international collaboration outside of the topic of environmental impacts, we could really have international cooperation that can take several forms. And maybe to highlight just two of them, one of them would be targeted policy and financing efforts, where governments can really strengthen collaboration across the value chain by using co-investment strategies, joint ventures, and offtake agreements. And we've been seeing some of this coming up recently with co-investment between Japan and Australia, or Japan and Malaysia, Japan and the United States. So these kind of agreements really help, but also public participation can help share the risk and attract private capital and support coordinated development of supply chains. And then on another topic that could benefit from international coordination, that would be harmonization of magnet performance standards. Today, magnet performance standards are really fragmented across markets, and harmonizing these standards would really enable manufacturers to scale up the production of permanent magnets. And today, really differing national and industry specifications for properties such as coercivity, thermal stability, corrosion resistance, etc., create barriers to trade and slow down the qualification of new suppliers. So greater alignment on harmonized standards and performance benchmarks would lower the certification costs and facilitate the interoperability across global value chains.
Thanks very much indeed, Amrita. So we're approaching the end of our hour. So I'd like to turn to first Benjamin, and then maybe also to Ewan for a couple of words at the end. We didn't get to all the questions, and I fear that we may not have ways to get back to all the people who put comments into the Zoom Q&A. So if you would like us to respond directly to your question, there's a generic email address for the IEA Critical Minerals team, which is IEAcriticalminerals, all one word, @iea.org. So please don't hesitate to write to us, and we'll get back to you on that as soon as we can. But can I turn to you, Benjamin, for any sort of thoughts from your side on what we've discussed today, but also then, next steps from your perspective for the activities under the French presidency?
Thank you very much. So maybe first on the challenges, and I think the report highlights it very clearly. There is more effort to be done on magnet manufacturing. I mean, a lot has been done already on mining and refining, and of course there are challenges, but I mean, we see with the project we have in France, by the way, in cooperation with Japan, to separate heavy rare earths. I mean, the plant can be completed in 20 months with no difficulty, no problem, and the financing is there, and it will be up and running next year. So, I mean, in two years, it's possible to develop a separation plant. It's not science fiction, and it's not a €1 billion investment. It's much more, 200 million, $300. So it's feasible, and we have to continue the effort. We have to continue the effort on mining, and obviously, as you mentioned, Southeast Asia is very important. We have an agreement with Malaysia. We are doing transfer of technology of separation in Malaysia, because of course this country wants also to separate the rare earths locally and do magnet manufacturing, and we are totally okay with that. And we do, transfer of technology is something we are doing in rare earths for now a lot of years with Australia, with Malaysia, and it's very important because it enables a lot of countries to use this technology. But clearly, the magnet manufacturing side is still challenging, and I fully agree that one big difficulty is the supply side. Because we will have a rare earth separation facility, we will have rare earth supply, but if there is no a big offtake agreement by a downstream user to a magnet manufacturer, then there will be difficulty, and that's one big focus. Coming back to G7, we have is to complement what we already have done on the supply side, and which we have to continue and to increase, with demand side and market organization, because obviously the market by itself is not adapted to solve this problem of diversification, and we have to put additional regulation, whether it is supply side or market organization, market protection, price environment, and these are the things we discuss currently on the G7, and hopefully we will be able to agree on principle framework, and this will be also a strong signal on the downstream sector to accelerate its offtake and purchase and its contribution to the investment, and also a signal to the market in general that these investments that they are doing it's true difficult, that were difficult in the past because of the market uncertainties, volatility, non-transparency. Then now we have a good framework environment. We have government that are committed to invest. We have an equity fund in France, the same Germany, the US government is investing. We are all putting a lot of effort. And then if we complement that by the demand side measure and the market measure, I think there will still be technical challenge. There will be a lot of work to do, but at least the momentum will be very high, and that's our priority for the next week, and for also the second part of the year, which is implementing all the measure I mentioned on stockpiling, on transparency. Very technical measure, and frankly, once again, thank you very much for all your analysis, because that's really what we need. We need, fact-based data, very good synthesis of data, and value chain analysis, because this is the way to build a good policies.
That's good. Thank you so much, Benjamin, for that. We're going to close now, but before doing so, last word to the head of our critical minerals division, Tae-Yoon Kim.
Yeah, thank you. So after this report, and just wanted to announce that there will be 2 follow-on reports about this topic, critical minerals, and in the coming months. The one will be on supply chain traceability for energy and economic security. That will be published in late this month, and also in middle of this year, we will publish this year's Global Critical Minerals Outlook 2026, which will contain full update about demand, supply projections, and together with some deep dive analysis. So I wanted to ask you to stay tuned for that. And then just to thanks for team for guidance, and Benjamin for your support, and the Amrita for leading this excellent analysis, and the all colleagues contributed to Eric, Alex, Jovan, Alessio, Ken, Marie, Joyce, Nicolas, Amin, Felix, all very much thankful for this contribution, and also thanks to our esteemed peer reviewers and the delegate from the Working Party on Critical Minerals. Thank you.
That's grand, Tae-Yoon, and that is where we will leave it for today. I understand a recording of this video will be available on the IEA website, and we look forward to have you joining us for future discussions on these very important topics. Thank you so much for joining us today, and I hope to see you soon. Bye-bye.